All right, let's go over some problems about rules of fractions. So in these problems, I'm asking you to simplify each expression into a single fraction. So in the first one, we're adding two fractions. So whenever you're adding or subtracting fractions, if they have the same denominator, you can add them directly. Just add the numerators together and put it over that denominator. But here, I don't even know what these denominators are, but they're definitely different. So I'm going to need a common denominator. So that means I'm going to multiply each fraction by something divided by itself, and I got to do this strategically so that I end up with the same denominator. So I want to end up with a denominator that has a times a minus 2. So for the first fraction, I'm going to multiply it by a minus 2 over a minus 2. And I'm allowed to do this because a minus 2 over itself is going to equal 1. You can multiply anything by 1 anytime you want. You will never damage anything or cause any mistakes. Go around multiplying everything by 1 as much as you like. For the second fraction, I'm going to multiply that one by a over a. So you see what I did was take the other fraction's denominator and use that for my common denominator, for creating my common denominator. Okay, so when you're multiplying fraction times fraction, you do top times top and bottom times bottom. So on this one, I have 2 times a minus 2. I'm not going to expand it just yet. I never expand or distribute things unless I have to. And this is over a times a minus 2. And then in the second fraction, I have 1 times a, which is just a, over a minus 2 times a. So these denominators are the same. I just have the factors in a different order. But multiplication is commutative, so that's fine. Okay, so now on the next line, I'm going to add these two fractions together. So I'm adding, now that they have the same denominator, I'm adding the tops together. So I'm going to have 2 times a minus 2 plus a, and that's all over a times a minus 2. And now I see to simplify this, I need to gather like terms on the top, but first I'm going to have to distribute the 2 into the parentheses here. So I'll go ahead and do that. So I have 2a, and then I'm multiplying 2 times 2, so it's minus 4, and then plus a. So I knew that was going to happen, and now I can combine this 2a and this a to get 3a. On the bottom, however, I would not distribute the a. I don't think it makes it any simpler. Simpler usually means shorter. So I don't think the bottom will get shorter if I write it as a squared minus 2a. I don't think it's an improvement. But at least for the top here, I'm ending up with 3a minus 4. I do think this is shorter than the version over here. So that's why I did that. Okay, and I think this is about as good as it's going to get. So we'll stop here. And I'm putting a box around my final answer. Let's look at another problem. So number 2, I have a fraction within a fraction. So now I'm going off my lines here. 1 minus 1 over x, and that's all over x. So I want to simplify this so that only one fraction appears. So I'm going to work on simplifying. Well, there's a few ways you could do this, actually. I think one way would be to simplify the top part first. So maybe let's do it both ways. So one way, and then I'll do another way over here later. So draw another arrow, another way. And then I'm not going to let these two meet each other. So I'll keep them separate. Okay, so one way would be to simplify the top first and turn 1 minus 1 over x into a single fraction. So to do that, I would start by writing the first part 1 as a fraction by writing it as 1 over 1. And then I'm only going to change the top, and then I'm just going to kind of keep copying the over x part. But now I have a fraction minus a fraction up here, so I can get a common denominator. I never need to introduce a factor of 1 anywhere. Everything already has a factor of 1. So what I'll do is I'll multiply the 1 over 1 times x over x to get the x factor in there. Well, that sounded like a pun or something, the x factor. And then this is still all divided by x. Okay. So now on the next line, 1 times x, 1 times x. This is just x over x. And I'm just copying the rest of it over. Now I have two fractions on the top here with the same denominator, so I can just add the numerators, or in this case, subtract them. So this is x minus 1 over x, and that's all over x. Now you have to be a little bit careful to remember to make sure that this line in the fraction is shorter than this one, so you know this fraction is the one in the top, or you could put parentheses like this. Okay, now at this point I need to do something about this x in the bottom. So there's a few ways you could do this, but one way would be to realize that x is the same as x over 1. And now you have a fraction divided by a fraction. So when you have a fraction divided by a fraction, you take the fraction on the bottom, you take the reciprocal of it, and you multiply that by the top. So here's the top, and here's the reciprocal of the bottom. Reciprocal means flip it upside down. Okay, and now I could just simplify a little bit. So I have a fraction times a fraction. So top times top, bottom times bottom. So x minus 1 is times 1. That times 1 thing doesn't change anything. So this is x minus 1. And on the bottom, I've got x times x, so that is x squared. Okay, so now I've written it as a single fraction. Here's another way you could have done it. So forget about that way. Go down here now. So whenever you have a big expression divided by something, or whenever you have anything divided by something, dividing by something is the same as multiplying by 1 over that thing. So for example, dividing by 2 is the same as multiplying by 1/2. So what I could have done is, right at the very beginning, I could have pulled this over x thing and written that as the same as multiplying by 1 over x, and then write that next to the numerator, like this. So dividing by x is the same as multiplying by 1 over x. And then I could have basically done the same process that I did on the right-hand side. I would need to get a common denominator between these two, and then multiply that by 1 over x. So you see, I would have ended up the same as how I ended up here, multiplying 1 over x times the combined numerator. So I'll just put etc. here. It's the same from there on out. All right, let's do one more. So number 3, we're going to simplify 1 over n times n plus 1/2 into a single fraction. Okay, so just like I would have done up here, I'm going to get a common denominator between n and 1/2. So n is the same as n over 1. And now I need to get a factor of 2 into n over 1. So I'm going to multiply that by 2 over 2. And I don't need to introduce a factor of 1 into 1/2 because everything already has a factor of 1. Okay. So n times 2 is 2n. So now I have 2n over 2. Then I have 1 over 2. And now I'm adding apples and apples. So I can just add the numerators. So this is 1 over n times 2n plus 1 over 2. All right, so now I have a fraction times a fraction. So top times top, bottom times bottom. Again, multiplying by 1 doesn't do anything, so the top is just 2n plus 1. And then n times 2 is 2n. Now I've got it written as a single fraction, and I don't see anything else to simplify. So I'm going to call that the final answer. Oh, I forgot to box this one. And that's it.